Homo Universalis video number 3, Mathematics, Calculus Part 2, Arc Length. Huge thanks to the channel Professor Dave Explains for inspiring this video. Arc length is defined as the length of a curve f of x on a domain a to b. Arc length is used for many purposes, such as calculating the circumference of an ellipse, the length of a logarithmic spiral, and even the surface area of a solid of revolution. We will go over all of these procedures in a later video. Now, let's take a look at a graph of the polar equation r equals 1.25 to the power theta. The arc length from the red points A and B is defined as the length of a path from point A to B which follows our equation. Let's zoom in on the graph of r equals 1.25 to the power of theta on the closed domain from negative 1.55 to 0.62. We'll choose 2 points which we will use to calculate the arc length. The point P sub 1 has the coordinates x0, f of x0, while the point P sub 2 has the coordinates x sub 1, f of x sub 1. In order to derive the distance d between P sub 1 and P sub 2, we will drop 2 perpendicular line segments which meet at the point x sub 1, f of x0. The distance between our right angle vertex and P sub 2 is delta y, while the distance between it and P sub 1 is delta x. Using this knowledge, we derive that the distance between P sub 1 and P sub 2 is the square root of delta x squared plus delta y squared. Let's perform an algebraic manipulation on the radicand. We'll factor out delta x squared, which leaves us with delta x squared times 1 plus delta y over delta x quantity squared. After taking out the square root of delta x squared, we get the absolute value of delta x times the square root of 1 plus delta y over delta x quantity squared. Since delta x can only be positive, we can drop the absolute value. Now, let's use the mean value theorem to get a better approximation. According to the mean value theorem, there has to be a point between our closed interval from A to B that has a tangent line equal to the secant line between the two endpoints. We will label that point x sub I star, f of x sub I star. This turns our equation into the square root of 1 plus f prime of x sub I star squared, quantity times delta x. Knowing that this distance could be any point on our closed interval, we will sum this equation as I goes from 1 to n, where I is the amount of subintervals. Finally, taking the limit as n approaches infinity will give us the exact arc length. We now have a Riemann sum of the form of the limit as n approaches infinity of the sum of f of x sub I star times delta x as I goes from 1 to infinity. This Riemann sum is equal to the definite integral from a to b of f of x dx. Hence, our sum is equal to the definite integral from a to b of the square root of 1 plus f prime of x squared dx. This is the final formula for the arc length, usually denoted by the letter S. Let's evaluate the arc length of y equals 2x at the closed interval from 2 to 6. We will use the arc length formula which we had derived in the prior example. The derivative of 2x is 2, and 2 squared is equivalent to 4. Therefore, the arc length is the definite integral from 2 to 6 of the square root of 1 plus 4 dx. This simplifies to the definite integral from 2 to 6 of radical 5 dx. Since radical 5 is a constant, we derive radical 5 times x evaluated from 2 to 6. This is equal to 6 radical 5 minus 2 radical 5, which is just 4 radical 5. Hence, the arc length of y equals 2x on the closed interval from 2 to 6 is equal to 4 radical 5. Now, try one on your own. Find the arc length of y equals 2/3 x to the power of 3/2 on the closed interval from 1 to 3. Thanks for watching. Subscribe to Homo Universalis and like this video. Thanks to the vote of the viewers, we can expect a video on the Opium Wars anytime soon. Fiat Lux.